have been a logistical nightmare. How did they do it? One answer lies on the island of Salamis, not far from Athens. Here, discovered on a church wall, was a stone carving. Today, it is in the Piraeus Museum. Architect Mark Wilson Jones believes the enigmatic Salamis stone, depicting an arm, hands, and feet, may be a conversion table for the different measuring systems, Doric, Ionic, and Common.
This is a tracing I've done that shows the stone, and you can immediately see how the main measures work. We have this foot rule here, that's 327 millimeters, more or less, the Doric foot. And here you have a foot imprint that's roughly 307 millimeter long foot, which we tend to call the common foot. And there are in fact other feet. For example, this dimension here is one Ionic foot. So there's a kind of whole network of different interrelated measurements here.
The Salamis stone represents all the competing ancient Greek measurements: the Doric foot, the Ionic foot, and for the first time, the common foot, virtually the same measurement we use today. Wilson Jones finds evidence of all three measuring systems in the height of the Parthenon.
That distance is at one at the same time 45 Doric feet, that's the ruler on the relief. It's also 48 common feet, which is the foot imprint, and it's 50 Ionic feet, all at the same time. And these are quite exact correspondences.
So the Salamis stone may have provided a simple way for ancient workers from different places to calibrate their rulers and cross-reference different units of measurement. But the Salamis stone may also be a clue to how the ancient Greeks were using the human body to create what we now regard as ideal proportions.
What's extraordinary about this is that at the same time as being a practical device, it's also a kind of model of theory, architectural theory, that the perfect ideal human body designed by nature is a kind of paradigm for how architects should design temples.
Among the first to record that Greek temples were based on the ideal human body was the Roman architect Marcus Vitruvius. He studied the proportions of temples like the Parthenon in the 1st century BCE, 400 years after it was built.
Vitruvius' work gives us the overall frame which is necessary to understand the system of proportions of the Parthenon.
According to Vitruvius, Greek architects believed in an objective basis of beauty that mirrors the proportions of an ideal human body. They observed, among many examples, that the span from fingertip to fingertip is a fixed ratio to total height, and height is a fixed ratio to the distance between the navel and the foot. 2,000 years after the Parthenon, another artist was also searching for an objective basis of beauty.
This is a very famous image. It's drawn by Leonardo da Vinci in the Renaissance, and it's based on Vitruvius' description of the ideal human body, and it encapsulates this idea of its theoretical importance. And what's really interesting for us is that when we superimpose the Salamis relief on this drawing, we see that there's a remarkable correspondence. There are differences, but it's the same principle. You have the same interest in the anthropomorphic principle of giving a kind of sacred, fundamental justification for these measures.
Da Vinci's ideal Renaissance man famously stands in a circle surrounded by a square. Da Vinci named this image Vitruvian Man, after the Roman architect. The ratio of the radius of the circle to a side of the square is 1 to 1.6. That ratio is sometimes attributed to the Greek mathematician Pythagoras, who lived 100 years before the building of the Parthenon. In the Victorian age, it became known as the golden ratio. It was a mathematical formula for beauty. For centuries, many scholars believed the golden ratio gave the Parthenon its tremendous power and perfect proportions. Most notably, the ratio of height to width on its facades is a golden ratio. Today, the golden